everyone, and welcome to today's webinar, FIPS Certified Containerization, Docker Security for Public Sector. Before we get started, I would like to go over a few items so you know how to participate in the event. You have joined the presentation audio using your computer speaker system by default. If you would prefer to join over the telephone, just select telephone in the audio pane, and the dial-in information will be displayed. You will have the opportunity to submit text questions to our speaker today. Please type those questions into the questions section of the control panel to receive a response. We will take these questions throughout the presentation. Finally, today's webinar is being recorded, and you will receive a follow-up email to view this recording. I would now like to introduce our speaker, Andrew Weiss, Lead Federal Sales Engineer at Docker. I will now turn things over to you, Andrew.
Thanks a lot, Melanie. So thanks everyone for joining today's webinar. If you haven't already seen the announcements, we do have some exciting news to share, and we are going to share some more details on the announcement that we made a few weeks back, namely our pursuit of FIPS over the last couple of years has since been completed, and we're now a FIPS certified container runtime, and we're going to talk about what that means. We're also going to talk about how that fits into the public sector security story overall. So without further ado, one of the things I want to hit on at a high level is that, we have been taking security seriously and taking the enterprise seriously for quite some time now. And recently, Forrester came out with an Enterprise Container Platform report. And as you can see, Docker and Docker Enterprise is in the leader quadrant. Forrester has denoted us as leading the pack and making containers easy to use and easy to consume. And we're going to talk about how Docker Enterprise fits into the security story today and our new FIPS announcement and how that addresses the federal security and compliance state. But this is a really great report. If you haven't seen it, it is up on our website and it's easy to download. And you can take a look at all of the details of the report and how it addresses some of the different pieces of our offering. Now, I also want to talk a little bit about what the analysts are saying, what the community is saying about container security in general. And this came out earlier this year. This is Enterprise Management Associates that conducts an annual survey. This survey is top 10 priorities for container management and DevOps in production and at scale for 2018. The respondents are mostly large enterprise customers, or large enterprise companies rather. And they noted that the second priority of 10 is around security and compliance. And achieving a consistent security and compliance framework. And you can see that, that not only is it a top pain point for a lot of organizations today that are looking to adopt container technologies and adopt container platforms, but it even identifies some of the top standards and regulatory technology frameworks that organizations are after today or have to comply with, namely around HIPAA and FISMA, specifically when we talk about public sector and so forth. So I thought this is a really interesting survey. We'll talk about how FIPS kind of helps to address some of these requirements. Now, if you're fans of Gartner, Gartner has recently published some content. Actually, this came out a couple years back, and they've enhanced some of this reporting. But Gartner argues that containers or applications deployed in containers are arguably more secure than applications deployed on the bare OS and arguably on a VM. And Gartner has a really fantastic report here that came out a couple years ago. And like I said, there's some new content that they've been publishing throughout a series of blogs and so forth over time. Now, today we're hyper-focused on security, but I want to remind everyone that Docker Enterprise is not just about security. Docker Enterprise is about giving our users choice to deploy on any platform and on any infrastructure and do so in an agile manner. So whether or not you are addressing legacy applications on Windows Server infrastructure that is outdated, or if you're containerizing new applications and building new microservices architectures with new application frameworks, Docker Enterprise is really that only holistic platform that gives you the choice to deploy across all of those infrastructures and for all of those application types. And of course, you can do that on top of a secure foundation with accreditations like FIPS and others that will help you deploy it in an agile manner and in highly regulated environments. Now, just to review, for folks that are just still getting acclimated to container technologies, I want to remind folks, or kind of level set, what containers really are and how they fit into the existing ecosystem. If you're just getting started with containers, you have a set of secure infrastructure that you're deploying to, and that infrastructure could be physical hosts on bare metal. That could be virtual machines running on top of virtualization architectures like Hyper-V, VMware, and so forth, or it could be on cloud providers like Azure or AWS. On top of that infrastructure, you'll run what's known as the Docker engine or the Docker daemon. This daemon provides the core functionality necessary to spin up containers and put whatever you want into those containers. So whether or not you're deploying legacy applications in those containers running on .NET, or if you have statically compiled binaries that act as maybe web servers or run scheduled jobs, the choice is yours as to what you want to run in these containers. And Docker makes it really easy to create these isolated execution environments, which contain the libraries and the binaries you need to host your applications and allow users to easily connect those applications. The cool thing about container isolation mechanisms is that all of these applications can run side by side on the same hosts, all supported by the Docker daemon, and they can operate completely independently from one another. So as you can see in the diagram here, the application A running in a container is completely separate from application B, which has its own set of libraries and binaries used to support the application. And of course, as we'll see, App A could be a .NET app, App B could be a Node.js application or a legacy Windows app, and App C could be a one-time task like a scheduled job or of sorts. So you have a lot of flexibility as to what you can run in your containers, and of course Docker gives you those isolated execution environments and the portability you need to move those containers to any host OS and any infrastructure. And this diagram kind of shows that at scale. You can see underneath you have a plethora of infrastructure options that you can deploy containers to, whether you're looking at multiple different Linux distributions, or if you're deploying on top of Windows and Windows Server, or looking at the mainframe or different cloud providers. You can do all of that, or you can address all of those types of infrastructure using a single engine and a single platform, and that gives you the flexibility to deploy your containers across these infrastructures without having to rewrite your applications for those infrastructures or re-architect all of the different components necessary for high availability or disaster recovery. Docker Enterprise really makes that easy, and it gives you that agility and scale to deploy across those infrastructures. So with that being said, I want to kind of focus in on what today's announcement entails, or the announcement we made a few weeks ago, in that we are now FIPS 140-2 validated. And if you haven't seen, we made a press release about this, and you can see some information on our blog. We are today the only container runtime that is available with FIPS validated cryptography. And what this means is that the cryptography module that we've implemented into the Docker engine has met the requirements set forth by the government and the FIPS 140-2 validation program and the testing harnesses that are included with that program. Now, this module is only available as part of the Docker Engine Enterprise offering. This is the engine that is available only as part of the Docker Enterprise product platform. And it allows you with this crypto module to process any sort of sensitive information to satisfy requirements mandated by FISMA. So if you think about the requirements for deploying systems under low, moderate, or high, if you're looking at FISMA baseline, or if you are a systems integrator or a company that's looking to build ISV solutions on top of cloud service providers and meet FedRAMP requirements, ensuring that you can protect the sensitivity of that information, of course, is paramount. And Docker Engine Enterprise with this FIPS mode, with this FIPS validated cryptography, gives you all the pieces necessary to do that. And you may see other rumblings around FIPS and FIPS 140-2 in the context of containers, but it's important to note that the module that we're using in the engine is validated cryptography. And if you look at some of the requirements set forth by NIST, any unvalidated cryptography is equivalent to providing no protection to the information or data. So of course, with this validation effort that we've achieved, it helps to satisfy that requirement. Now, digging in a little bit deeper for folks that are a bit more acclimated to the Docker engine and the Docker platform, what are the specific capabilities that are supported by this validated module? Now, this list is not 100% comprehensive. There are a couple of nuances to this list, but at a high level, it does cover all of the ID hashing mechanisms. So every time you create a container, there's an ID that's assigned to that container, or if you create some sort of Docker object using the CLI tools, those hashes are created using cryptographically assured mechanisms, and specifically with the FIPS validated module. Also, the underlay that we use to actually establish communication across a Docker enterprise cluster, if you're not familiar with how that works and the swarm mode capabilities that we implement, everything is encrypted in transit, and all of the metadata for a cluster is encrypted at rest using a mutual TLS implementation that we have. That entire implementation is also protected by our FIPS validated cryptography. That also encompasses a couple of other capabilities around that architecture, namely around encryption at rest of certain objects, Docker configs and secrets, and other networking components around overlay networks. And also lastly, if you choose to enable a TLS binding or socket binding for the daemon, you can do so and also get assured mechanisms using that FIPS validated cryptography. And not only do we have FIPS validated cryptography in the engine, but to give you a sense of where Docker Enterprise is being used across public sector and specifically in the federal government, in addition to FIPS validated cryptography, we have multiple agencies that have achieved authorities to operate or authorizations to operate for the entire Docker Enterprise platform. That's at various baselines from moderate through high, and also DoD impact levels 2 and 4 through 6. So if you are a compliance professional or if you are a risk assessor, these may be meaningful to you in those contexts. We also work in law enforcement and also are compliant to the CJIS security policy requirements. And of course, Docker is also listed on various DoD and civilian agency software listings and has attestations across the DoD in various capacities. And then lastly, for Section 508 accessibility requirements, we are working towards creating a VPAT for the entire Docker Enterprise platform. So needless to say, this FIPS validation really helps to complete that story holistically for addressing public sector security requirements en masse. And to round that out, not only are we checking the boxes per se in terms of public sector security, but we've also been at the forefront of the development of container security standards. If we think about, the standards that exist today, oftentimes they're not well aligned to the dynamic and ephemeral nature of the evolution of technology. And if you are familiar with containers, containers provide these agile and portable execution environments for applications, but at the same time, they're often not stagnant. They're not long-running systems, and it's difficult to align a security control plan with that changing or ever-changing nature of the containerized application. So we've been doing a lot of work in direct coordination and direct partnership with the National Institute of Standards Technology. Not only have we delivered the first FIPS validated crypto as part of a container runtime, but we've also been contributing to the development of existing security standards and also contributing to net new standards around container security. So we've been working with various teams across NIST to address standards like NIST 837 and new series of publications that have been developed or being developed as part of the NIST National Cybersecurity Center of Excellence. And also, if you've seen NIST 800-190, which is a container security guide for Linux, we've also been contributors to that as well. So needless to say, we've been taking the space very seriously and working very closely with NIST to address security requirements en masse for various standards and FISMA needs. So that, one of the things I want to do is step back and talk about, at a high level, what are some of the threats and concerns that we have to take into account, with security in general in the public sector, and how can Docker Enterprise mitigate all those threats and concerns? And we've lumped these into a set of different buckets, and these buckets coincide with some of the questions that we get asked quite often from our public sector customers, namely being, how do you protect the source code and build environment for applications? We're building applications that are mission critical. They may be sitting on the back of a Humvee, or they may be processing sensitive data, whether that be payment card data or sensitive health information, we want to make sure that the source code being used for those applications is secure. And of course, when we use containers, we want to make sure that that is secure as well. And then also, we get a lot of questions around operating system level security and how do I prevent things like container breakout. And I'm hearing about, root on the host is root in the container and vice versa. So, there's a lot of different protection mechanisms that exist today, and also new protection mechanisms that are being developed to address a lot of these concerns, and we'll talk about these as well. And then, of course, there are security things that are specific to Docker itself. So how do I configure the runtime? How do I enable FIPS mode? What are the things that I need to consider if I want to adopt an orchestration strategy around Kubernetes or Swarm mode? We'll cover these things, and we'll also cover how Docker Enterprise and how this FIPS announcement addresses some of these concerns. So I want to start off with source code and build environment. This is an area we get questions on, but we also present this such that folks are new to this. It's usually not top of mind in terms of security in the build environment. Developers want to ship applications as fast as possible, and oftentimes security kind of slows them down. It makes it more difficult to develop applications in an agile manner if I'm getting stopped, every few days to go back and address certain things or to do things in a certain way. And oftentimes this results in insecure coding practices, and it leads to vulnerabilities in that continuous integration and continuous deployment process. Now, one of the things that we've seen folks use to address this is to actually containerize much of their CI/CD or that whole continuous integration deployment workflow. By actually executing all of these steps in containers, you can give yourself an isolated execution environment for your staging, for your unit testing and your integration testing. You can run your CI/CD tools in the containers themselves. Folks that are using tools like a Jenkins or a GitLab and executing those environments in containers. We've also seen even hosted providers that offer their services in containers themselves. So needless to say, this is a tried and true mechanism in terms of containerizing the actual CI/CD environment. The other area we get questions a lot on is around operating system level protections. We get a question in terms of, if I'm using containers, do I still need to worry about the host OS? Well, if you saw in the earlier diagram, if you notice in the early diagram, Docker itself relies on a host operating system to deploy containerized applications. Docker relies on the underlying kernel in Linux and also relies on the underlying primitives in Windows Server to actually spin up containers and provide you with that isolated execution environment. So it's still imperative that you secure your host operating system. And what we're starting to see are folks use even smaller footprint distributions or small footprint OSs with only the bare essentials that they need to actually containerize applications. So the processes that you have today are still going to apply when using containers. But in addition to that, you get all the enhancements and capabilities provided by a container platform. So using minimal OSs, leveraging security profiles included or provided by your distribution like SE Linux, AppArmor, and what have you. And also traditional hardening mechanisms. You're still going to look towards CIS benchmarks and STIGs to harden those OSs. And in some cases, you may look towards managed services that provide some of that abstraction so you don't have to manage the OS to leverage container technologies. There's a lot of different options you have here for providing OS level protections. Now, high level, I'll just cover briefly some of the isolation mechanisms provided under the hood that actually make containers work. If we think about the core primitives provided by Linux, this is provided by technologies known as namespaces and control groups. These things have been around actually for quite some time. Namespaces have actually been in the kernel since around 2008, and they provide kind of the most straightforward form of isolation that exists. And Docker really taps into this technology to enable containers at their core. And control groups allow for resource allocation and accounting for each of those containers to ensure that each container gets its fair share of memory, CPU, I/O, etc. Now, the thing to note here is that this is a very basic form of isolation. So this does provide some subset of security functionality, and a lot of this is abstracted from users when they actually spin up containers. So you never have to worry about all the individual system calls that are made to these kernel primitives, but they do provide some subset of security isolation and the core functionality needed by containers. And on Windows, it works very similarly. There are technologies known as silos and job objects that work in an analogous fashion to namespaces and C groups. At the end of the day, these technologies provide for container primitives that give you a very basic level of secure isolation for those workloads. Again, on the Windows side, you're looking at .NET applications or web server applications or anything that runs server-side and headless today in a Windows environment. You cannot do so in a Windows container, and these kernel primitives give you that flexibility. Now moving right along, so we've gone from the old source code environment, we've talked about OS level protections. Let's talk about infrastructure level protections. In a lot of ways, the infrastructure that you're building on gives you a lot of additional protections that go above and beyond just traditional host OS. And the beauty of Docker Enterprise is that you can deploy across any infrastructure and take advantage of all of those different protection mechanisms. So if you're thinking about a traditional data center and you're leveraging hypervisor-based protection mechanisms or anti-affinity-based mechanisms, or if you're looking at a cloud service provider where there are some new technologies that are allowing folks to physically or logically segment infrastructure, you can deploy Docker Enterprise on those platforms and get those security assurances for your entire system and not just the individual host OS components. One of the things that we're starting to see from folks in the public sector is this notion of automated infrastructure recycling, meaning instead of having these long-running stagnant systems, continuously recycle them and destroy them and recreate them. Data is often backed up and can be easily moved to different data centers or different cloud regions, and the cloud providers themselves make it really easy to spin up infrastructure in an automated fashion. And you can combine this methodology with Docker Enterprise to develop this notion of quote-unquote moving target defense, where your infrastructure is always moving and you always recycle your infrastructure with the latest patches and the latest releases of the enterprise product and the underlying host OSs that are supporting them. Now shifting into the specifics for Docker container security itself, for folks that are starting to build more mature software development lifecycles using containers, one of the core aspects of a container is this image or this package. This defines the blueprint for your containerized application. What's going into that blueprint are the dependencies and the libraries and the actual compiled source code itself. So it's imperative that you actually know what's going into these images. And I'll talk a little bit later about how Docker Enterprise gives you that introspection capability so you can identify what is going into your images and prevent any sort of vulnerabilities from making their way all the way into your production runtime environment. I talked about shrinking the host OS and making it as small as possible, or using minimal OSs to host Docker. You should think about the same thing when we talk about container images themselves. The smaller your containers are, the smaller those container images are, the faster those applications will be able to spin up, the more condensing or consolidation you'll have on a smaller subset of infrastructure, therefore saving you on compute costs. And of course, the better security posture you'll have, there's less running in that container that could potentially be compromised, and it gives you that secure agility across different platforms. So you should really only include what's necessary for those applications in containers, and that starts with using the smallest possible base image for those containers. Examples of this include technologies like Alpine Linux or Microsoft's NanoServer base image variant, both of which have a lot of dependent or inherited images on top of that. A couple of other capabilities that you definitely want to look at in terms of image security is around both vulnerability scanning and content trust integrity checking. Vulnerability scanning meaning, how do I ensure that all of the packages that my image contains and all the things that are going to actually be in my container when it's running have no vulnerabilities associated with them. So of course, Docker Enterprise product gives you the ability to scan your images for vulnerabilities and do that level of analysis to ensure that each binary, each package has no vulnerabilities associated with it, therefore giving you peace of mind throughout your software delivery process. Another capability provided is this notion of content trust. So how do we validate the integrity of our content, the integrity of our images from the moment that our software is built on a developer workstation, or how it moves through the CI/CD lifecycle from maybe the dev environment or the staging environment? how do we validate that our software hasn't been compromised or manipulated or somehow malformed throughout that process? Docker Content Trust gives you that capability, and it makes it really easy for you to sign your images and verify the integrity of those images throughout the supply chain. And with the FIPS validated announcement that we've made, you can actually now leverage FIPS validated cryptography to do these signing and integrity checking mechanisms. And then lastly, we want to make sure that we're using trusted base images, and we want to make sure that those images are configured so that the containers are not running as root. Now, root in a container isn't 100% equivalent to root on the host, but there are some security implications for running containers as root. So it's always recommended to avoid running your containers as root. And this slide here gives you an example of a Dockerfile that has been configured to run the container as an alternative user. This actually comes from one of the official Jenkins images. So as you recall, I mentioned that Jenkins is a popular choice for running Jenkins itself in a container. And this is what that image looks like for building that containerized variant. So this, of course, is running as an alternative user in the container with a UID and GID of 1000. And this user is set to be used at runtime when the container is actually deployed. This is just one example of how containers can be run as non-root. And connecting all of those pieces together, this is a typical environment that we see. This is kind of a generic diagram, but I'll show you how Docker Enterprise addresses all of these components of a CI/CD workflow. It all starts with the developers committing and pushing code, ensuring that code is scanned, so for secure coding practices, and then, of course, assuring that that's pushed to a CI/CD platform that is secure and addresses all the requirements that we mentioned a few slides back. And then once that source code is scanned, then we're going to have some sort of mechanism to automatically build our Docker images or our container images. We want to make sure that those images are, of course, scanned for vulnerabilities, and now we've given those images signatures using Docker Content Trust to ensure that those signatures can be validated to verify the integrity of the software as it moves throughout the lifecycle. And then we can use that information to effectively assess the risk for deploying this application, ensuring that it meets the requirements set forth by our organization. And we can subsequently trigger either a deployment or an ongoing auditing process for those applications. And this is a very typical workflow that we see across the public sector and folks leveraging with the Docker Enterprise platform. Last two pieces I want to hit on are around runtime security itself. So of course, the first big thing is ensuring that your containers are not running as root using the techniques described previously with your Docker files. But a couple of other things revolve around where the ecosystem is today. The Docker runtime is built on a core standard that was founded by us amongst a few others, known as the Open Container Initiative. And this initiative defines core specifications used to actually run and deploy containers and also build Docker images. And these specifications have very much matured over the last couple of years, and this has led to a maturing of the security ecosystem for container technologies. So vulnerabilities are very few and far between in terms of the runtime itself and the build mechanisms. And container breakout scenarios, we get this question a lot, they're increasingly rare and very difficult to actually pursue. You're much more likely to be compromised at different elements of the software supply chain. So that's why we have folks very much focus on things like Docker Content Trust and scanning your images for vulnerabilities, because those are much easier to compromise if you don't have a strong posture in place. And Docker Enterprise gives you those capabilities to make it really easy to address those requirements. Now, one of the things you certainly want to keep in mind is that there are some runtime properties that could expose yourself to some compromise. So, of course, things like published ports on the host or any sort of underlying host hardware access, all of these things can be gated using some of Docker Enterprise's role-based access control mechanisms, which I'll talk about shortly. And then, of course, with today's announcements, you can also now leverage FIPS mode in Docker Engine Enterprise to protect the sensitivity of the information that's traversing your enterprise cluster. So lots of enhancements here to address runtime security concerns. And orchestration is the same thing. So if you're looking at orchestration platforms like Kubernetes or Swarm mode, both of which are provided by Docker Enterprise itself, The security of these platforms has improved significantly over the last few years. But one of the challenges folks run into is that with orchestration comes a lot of things that you can turn on and off. And if you don't have processes and policy and governance in place, you end up with too many options, which in and of itself results in a poor security posture. So there's a lot of different things that you can leverage if you've built yourself a mature process and foundation for orchestration platforms. There's a lot of things that you can leverage to improve the security of the application deployments themselves. There's new service mesh technologies out there, and AAA paradigms or authentication, authorization, and accounting paradigms that you can deploy on top of Docker Enterprise. They make it easier for you to not only leverage new orchestration technologies, but also tap into some of the new frameworks for secure application communication. And of course, there's plenty of Docker primitives that you can take advantage of, many of which are built on the FIPS validated cryptography that we have for you to store sensitive application data like API tokens, connection strings, and so forth. Now we've hit on all of the, or many of the concerns that we hear from our customers. So I want to talk about how Docker Enterprise specifically addresses a lot of these concerns, all the security features that you get, in addition to the FIPS 140-2 validated cryptography across enterprise. Of course, Docker Enterprise provides 100% end-to-end security from the moment the software leaves the developer workstations all the way through runtime in production. We give you the tools necessary to build secure applications or containerize applications in a secure fashion and ensure that they're running on top of a secure infrastructure that encrypts the data in transit, encrypts the data at rest for all of that cluster interaction amongst other capabilities. I've been talking about this notion of a supply chain throughout the presentation. This is kind of what it looks like with Docker Enterprise specifically. So we want to make sure that we're securely managing our Docker images and our Docker containers. So checking those images for vulnerabilities and of course signing them using content trust mechanisms. We also want to make sure that our software is being properly promoted given the processes that we've defined as an organization. So how do we know that the software has met certain requirements before it's moved into production? Well, Docker Enterprise gives you that policy-based promotion mechanism, all built around the registry in Docker Trusted Registry. And of course, ensuring that once we've met those requirements and our software is ready to move into our runtime phases, ensuring that those runtime phases give us cluster encryption or secure cluster communication encryption, and ensuring that all of the compute resources that have been allocated in my cluster have been authorized and approved for use. And of course, that comes with some of the capabilities provided by the underlay in Docker Enterprise. This is a screenshot of what security scanning looks like in our Docker Enterprise product. This is specifically in Docker Trusted Registry. You can see here that I get a binary level scan of the vulnerabilities that have been associated with an image that I published to my repository. This particular image in the screenshot happens to be a .NET application based off a Microsoft-based image that's a little bit older. So I can actually see that this image has some vulnerabilities associated with it. The vulnerability scanner provided by Docker Enterprise gives you binary level introspection for all of the things that you've inherited from other images that are included with your image, and also information about the binaries that you yourself are compiling in your image. So we support scanning of the compiled DLLs or the portable DLLs that you've included, or any sort of Java application packages that you've included in your image. All of those are checked against both the NIST National Vulnerability Database and the MITRE CVE database. And in addition to vulnerability scanning, I've talked about this a few times now, you can establish a secure chain of trust for all of your application images. So ensuring that once the application code has left the developer workstation and moved into the CI/CD process, ensuring that that process is signing those images throughout the various stages. A signature is essentially a key value pair, or is created from a key value pair using Docker tooling and what we call Docker Content Trust. Again, that is built on FIPS validated cryptography. That signature is tied to an image over the course of its life cycle. You can attach multiple signatures to that image if you need to. So you can see here in the diagram, I have two signatures going into the staging environment. once the application has passed the security scanning mechanisms that I've incorporated. And then when it moves to production, I've attached a third signature to this same image that was built at the same point in time, meaning that by the time the application gets into production, I can use those three signatures to enforce integrity at runtime. So if for some reason any one of those signatures is missing or somehow malformed or compromised, I can actually use Docker Enterprise to prevent the software from even running in the first place. It gives you much better risk posture, much better risk control long before the software is even running in your production environment. And a lot of this can, of course, be automated. One of the other cool things about this, too, is that this also guarantees content freshness. So every time you apply a signature into an image, you assign what's called a snapshot or checkpoint to that image. And then over a period of time, if a certain period of time has elapsed, it'll actually alert you and say, hey, this content hasn't been signed in a certain period of time. This is a given risk to the environment if there are any sort of vulnerabilities introduced for some of that code. So you get a lot of different things out of this, all built around Docker Content Trust. And then lastly, we want to make sure we're deploying to a secure runtime environment. I talked about encryption of traffic in transit and, of course, encryption of metadata at rest. This is how that works. This is all built on a mutual TLS architecture. This architecture is the core foundation for our Docker Enterprise product stack. So you can leverage this architecture to deploy applications in a secure manner and also deploy objects to those applications like API tokens or connection strings, and ensuring that that data is securely passed to those applications at runtime. All of this is built on mutual TLS version 1.2. For the folks that want to get into the specifics, we use AES and GCM mode. All of this, of course, is built on our FIPS validated cryptography. We make it really easy to manage this environment, so you can do things like automatic certificate rotation. You can integrate this with an external CA as needed, and you can add additional layers of encryption across both our swarm mode orchestration system and with our Kubernetes that we include as well. And then, of course, FIPS mode itself. The Docker engine provides a really easy mechanism for actually enabling this FIPS validated cryptography. In fact, if you've deployed Docker engine on a host operating system that already has FIPS mode enabled, the Docker engine itself will automatically swap the built-in library with the FIPS validated library for all crypto functions that I mentioned previously. You can also explicitly enable FIPS mode in the engine if you so choose. So if FIPS mode is not enabled on the host OS, but you do want to enable FIPS mode in the engine, you can do that as well. And you can do this across multiple operating systems. We support the FIPS mode on both Windows hosts and also multiple Linux distributions across CentOS, Red Hat Enterprise Linux, and Ubuntu as well. And combining FIPS mode for secure information protection, we want to make sure that the applications, when they are deployed, are protected from misconfigurations and ensuring that only the right users have access to these environments. So Docker Enterprise includes a robust and granular role-based access control model that makes it really easy to define different organizational units that have control to different parts of the environment. An example of this you can see here, where maybe you have a testing environment or a staging environment. You can isolate these from one another and create multi-tenant scenarios that gives you secure environment zones and logical partitioning of your applications. So maybe you have low, moderate, high data and you want to separate those across the environment, or you have different application teams that are building different types of applications, or you have different missions. All of this can be built on a single cluster with multiple divided zones as needed. Secrets management is also core to the platform. I mentioned that this is also protected by FIPS validated cryptography. This allows you to store your API tokens or connection strings securely, and also in a secure fashion mount those tokens and secure data to your applications at runtime. None of this is written to disk in plain text. All of this is encrypted at rest using FIPS validated cryptography and sent to the nodes using the FIPS validated implementation of mutual TLS, or the crypto that's used in that implementation, and nothing is ever written to disk in plain text. So with that, we combine all of these elements to get a secure and cohesive software supply chain, ensuring that our content is built with integrity checking mechanisms using content trust, and ensuring that, of course, that leverages FIPS-validated cryptography, storing and scanning our images, and, of course, deploying those images securely at runtime in an isolated fashion and in an agile manner across different environments. Now we have a few minutes left. I want to use this time to kind of recap what we talked about and talk about how that fits into this notion of actually accrediting our systems. So we have all these great security features in place. We have FIPS-validated cryptography, but how does it truly address the core requirements for my ATO processes if I'm in FISMA, if I'm addressing PCI requirements? Well, let's step back and talk about the core objectives of information security. Of course, if you're not familiar with those objectives, we're talking about confidentiality, integrity, and availability. So with confidentiality, how do we make sure our information that's being processed by the system is protected from unintended exposure? Now, the core requirement here that, of course, Docker satisfies is this notion of leveraging FIPS-validated cryptography. So with FIPS-validated cryptography and with the new FIPS mode provided by Docker Engine Enterprise, we can better satisfy the confidentiality requirements in information security. And using that FIPS-validated cryptography, we now have better mechanisms to store things like Docker secrets, and we have a better mutual TLS architecture implemented at the core of the Docker Enterprise platform. We also talked about integrity at length, talked about Docker content trust and Docker certified base images, both of which can be used along with vulnerability scanning mechanisms to ensure that the integrity of our content holds true no matter who built the content or where it's been deployed. We want to make sure that we know who built the content and we know where it's being deployed to and in which phase of our development lifecycle it's going through. So, of course, these mechanisms can be used to satisfy integrity objectives. And then, of course, availability, ensuring that we have an enterprise-grade, tested, tried-and-true platform actually deploying our applications and providing that information being processed by the platform to our users and consumers in a timely and effective manner in an available fashion. And, of course, Docker is built on industry-standard tooling and feature sets and standards that I talked about that can be used collectively to achieve the availability objectives. Along with these core objectives, we also want to talk about risk management. So we've got our checkboxes in terms of FIPS, and we're deploying our applications in a secure manner. But we also want to make sure that we can attest to the state of our systems and attest to the state of our containerized environments using frameworks and governance risk management and compliance methodologies that exist in the same way that we do with our traditional systems today. The cool thing about Docker Enterprise and container platforms in general is that they give you the flexibility to deploy across different infrastructures, all while giving you a much more agile risk assessment capability, meaning you don't have to worry about addressing the entirety of your underlying system if you're running in the data center and then worrying subsequently about the underlying capabilities of your infrastructure in a cloud provider. Docker gives you the ability to inherit a lot of those controls, making it really easy to assess risk for all of those containerized applications. And of course, paperwork automation becomes critical because if we think about risk management today, risk management is also typically associated with lengthy paperwork. If we think about system security plans, maybe in the federal ATO process with FISMA or other attestation artifacts, automation becomes really critical in the context of risk management in containers, especially when you think about how quickly containers are spun up and moved to different infrastructures, and if folks are taking advantage of some of these agile mechanisms across infrastructures, it becomes even more paramount. Paperwork automation is taken into account. And this is kind of what that looks like, what I was just talking about in terms of flexibility of risk management across infrastructures. Typical environments exist on the right, where we have traditional long-running stagnant systems that we've accredited and attested to. But that accreditation boundary for an application encompasses the whole stack, not just the underlying system, but also the guest operating system. If we look at the accreditation boundary on the left, though, with Docker, there's one less part of that stack, one less layer that we have to worry about. By putting applications into containers, we only have to worry about the accreditation of the applications themselves, and Docker can inherit a significant chunk of the controls, security controls provided by the underlying platform. This results in faster accreditations and more usage of containerized environments across highly regulated industries. And one of the things I did want to touch on is that some of the work that we've been doing with NIST that I talked about earlier on, one of the areas that we've been focused on is around automated compliance and automated risk management. Leveraging the data and the different mechanisms provided by FIPS validation, secure runtimes, and so forth. We are working with NIST on the development of a new standard known as the Open Security Controls Assessment Language, or OSCAL for short. This standard will be used to provide for that paperwork automation. So automating the generation of the SSPs and the generation of your attestation artifacts. We are working on embedding this capability directly into Docker Enterprise, which will give you the ability to assess your environments and assess your system across different standards, whether that's FISMA and NIST 853 or PCI requirements. We hope to give you the flexibility to assess and enforce these requirements across different systems and then across different standards. And with that, I will turn it back over to Melanie and see if we have any other questions based on the content that was presented in today's webinar.